Our next lesson is on fractional exponents and radicals, and you're going to see that there's a connection between exponents and radicals. And we'll get to that in a little bit. First, a quick review. Some exponent laws. If you have a to the power m times a to the power n, our rule is that we add the exponents. Okay? If we should probably do a couple of examples here. What do I mean by that? Well, we do an example. Let's say if you have 2 cubed times 2 squared. Okay, this means 2, and if we add the exponents, it's going to be 2 to the power 5. Okay, which would be 32. All right, our next rule, if you have power to a power, what do? You multiply the exponents, so you would have a to the nm. Okay, as an example here, let's say we have 2 cubed all to the power 4. Okay, what do we do with the powers here? When we have power to a power, we multiply them. So you're going to have 2 to the power 12, which is a big number. Okay, I won't expect you to do that without a calculator. Okay, next one. Here you have a times b to the power of m. What happens here is that power is applied to both of these terms. If you remember the very first lesson of the year we did in class, and I said there's a couple of mistakes that people make, and I'll even give you the example we had in class that day. It was this. It was 3x squared cubed. Okay, what you need to do is you need to put this 3 on both pieces here. So you're going to have 27 x to the 6th. Okay. Next one. Well, this one's different. This one you may not recognize. Okay. And it comes directly from this rule down here. So let's go and do that one first. Okay. What's our rule when you're dividing exponents with the same power? You're going to subtract the exponents. Sorry, when you're dividing bases that have exponents, the bases are the same. Okay, so let's look at an example here. If you had, let's say, 2 cubed over 2 squared, this is 2 to the power 1, which is just 2. And I mean, that should make sense to you because 2 cubed is 8, 2 squared is 4, 8 divided by 4 is also 2. Okay, so why does that apply to number 4 here? Okay, what do we do with a negative exponent? Anytime you see a negative exponent, it will become a reciprocal question. The n becomes positive by making it a reciprocal. Okay, and why is this true? Well, let's look at this example. If you have 2 cubed over 2 to the power 4, okay, our exponent laws tell us to subtract those exponents. So you would have 2, what's 3 take away 4? You'd have 2 to the negative 1. Well, if we did this a different way, 2 cubed is 8, and 2 to the power 4 is 16. And 8 over 16 is 1/2. So you see how 1/2, so you see how half is the same as 2 to the power negative 1. Okay, so that's a new one. You might want to highlight that one. You're going to see that. Negative exponent is a reciprocal. It is not a negative answer. Okay. A to the power 0, well, anything to the power 0 is 1. Alright, these are just, I'm going to say common sense, but maybe not. We have to apply that m to both parts of the fraction. Alright, and here's where it goes different. We have not seen this before. What is a to the 1 over n? Alright, the rule here is that this is the same as the radical with a root n. So as an example, okay, let's say 4 to the power of 1/2. Okay, so what is n in this case? N is a 2. This is the same thing as saying the root of 4. A power of a half is the same as saying the root. Okay, the same. Now that n doesn't have to be a 2. Okay, for example, we could have 8 to the 1/3. That's the same as the cube root of 8, etc., etc. Okay, we'll practice that, but that's a new one. Alright, and so then the opposite of that is if we have an n as an index, this is the same as a to the power of 1 over n. Okay, these are the same thing, they're just backwards. And then we have this one. Alright, this one's a bit confusing. There's no 1 here. Alright, if this was a 1, we would say this equals to the root, the nth root of a. But it's not a 1, it's an m. That m is actually a power. Okay? So that's a bit of a tricky one to look at. Let's look at an example. If you had, let's say, 2 to the power of 3/2. Okay? What's another way of writing this? Well, if there was no 3 there and it was just 2 to the power of a half, you would have the square root of 2. But what is this 3? This 3 is a power. Okay, so the top part of the fraction becomes the power. The bottom part becomes the index. Okay, you might want to highlight that a little bit. Okay, so let's just write it out here again. If we have a to the m over n, the n is the index, okay, and the m is the power. So let's try a few questions with that in the picture. It says write in radical form. Well, what form is this? This is exponential form. It's the exponent form. The powers are exponents. We're supposed to write it as a radical and then evaluate. Notice no calculator. So what does 27 to the 1/3 mean? This is the same thing as the third root of 27. So that's radical form. And now I'm supposed to evaluate it. This equals 3. Okay. Let's try the next one. Radical form, instead of a half, I'm going to take the square root of decimal 49. And what? If I take the square root of decimal 49, this is going to be 0.7. Because 0.7 times 0.7 is decimal 49. Thinking back to that, why is that true? Well, when you multiply decimals, you ignore the decimals to multiply. So 7 times 7 is 49. And then because there are 2 decimal places, we have to put 2 decimal places here. Okay, next one. The power of 1/3, this means the cube root of -64. Notice I have to put the negative inside the radicand because there are brackets around the -64. Okay, and what is the cube root of 64? It's 4. What's the cube root of -64? -4. Okay, next one, try that. How can I write power of a half? It's the root of 4/9. And I know what the root of 4 is, it's 2, and I know what the root of 9 is, it's 3. Okay, try the next one. Cube, sorry, this is the cube root of -125. What does that equal? -5. Okay. Just when you kind of thought you were getting used to it, we'll go to the more difficult ones. And so here's my tip to you. whenever you see a number like this, a power that's a fraction where there's no 1 involved, okay, I'm going to write this statement here. Go small, then get big. So what I mean by that is always do the denominator first and then the numerator. So you're going to get small by taking a root and then go big with the exponent. I'll show you what that means in a second. Okay, so let's write this as the square root of 9. So that 2 means square root, and the 3 is out there. Now, can you evaluate this? Sure you can. You can take the square root of 9, which is 3, and cube it, which is 27. Okay, now the reason I say go small, then go big, can you do 9 cubed first, and then take the square root? Sure. But what's 9 cubed? I don't think you know that. And what's the 9 cubed is actually 729. What's the square root of 729? Again, I don't think you know that. It's easier to go small first and then big. Okay? Let's try the next one. So first thing we're going to do is apply the exponent laws here. So you have 9. What do we do when we have power to a power? Well, you multiply them. So you have 1/3 times 3/2. So that's 9 to the power of 3/6, which is a half. And that's 3. Oh, wait, we were supposed to write it as a radical. So you have to write it as the root of 9. And that's 3. Okay, this one messes everybody up because we haven't seen a decimal yet. Let me make this much easier for you. I'm going to write -32. And instead of to the power of decimal 4, I'm going to write 4/10. Okay? But I don't like 4/10 because I haven't memorized anything about the 10th root. So let me simplify this. So 4/10 is the same as 2/5. Now that you can change to a radical. It's the 5th root of -32. And then squared. Okay? So evaluating that, the 5th root of -32, that's -2. By the way, these will never be decimals. They're going to be nice numbers. Okay, like I wouldn't ask you the 5th root of 30 because we can't do that. But the 5th root of 32, that's 2. And then 2 squared, 4. Okay. I think it's time for you to try a few. The next exercise, I believe it's 14.